I'm Jonathan Sabo. I'm a solutions engineer at Tigera. I've been here for about a year and some change. Today we're going to talk about how to secure VMs and specifically EC2 instances inside of AWS. Let's see here. All right. So what we're going to go through some slides at first. We've got like 9 or so slides and just kind of set the stage and describe a little bit about the solution, Calico's host micro segmentation protection in AWS. Some of you are probably familiar with Project Calico. Tigera, we are the creators and maintainers of Project Calico. We do network connectivity and network security policy inside of Kubernetes. But we can also use that same capability to apply policy outside, well, to Kubernetes nodes, but also to VMs outside of Kubernetes nodes. And that's what we're going to be focusing on today. We're going to talk about the Calico host micro segmentation deployment considerations, some of the things that you need to think about before you get started. Kind of just like decide what OS am I going to use? Is this operating system going to work? Do I have the right kernel modules deployed, and what is the data store that I want to use? And we're going to get into some of that in just a little bit. And then we're going to deploy it all together live here. We're going to deploy the Calico HMS protection control plane. We're going to be using EKS. So we're going to be using the managed Kubernetes service inside of AWS. And we're going to be taking advantage of as much AWS tooling as possible. We've defined the base networking implementation in CloudFormation. And all of this stuff is available in that last URL you see, that github.com, Tigera Solutions, AWS Calico Host Micro Segmentation repo. If you just go to GitHub and you go to Tigera Solutions, it should be public. You should be able to see it. We'll drop a link to that inside of the chat. It'll be easy to cut and paste. Then we're gonna deploy. We're gonna launch an autoscale group, an example work like a set of VMs, or in this case, a single VM inside of AWS, and we're gonna manually install the Calico agent onto that host and configure it and register it with the control plane. And then we're going to do a simple Calico HMS protection network policy example. It's going to be a little bit interactive. So if you want to get a head start, open up a tab in your browser and just type in "what is my IP" and just save that for a little bit. All right. So let me see here. So let's get started. All right. So one of the challenges that face operators and people who are running workloads inside of various clouds, but specifically AWS, are the dynamic nature of cloud instances. So cloud instances inside of an autoscale group, they're continuously expanding and contracting based on different performance characteristics or CPU utilization or memory utilization. And when they're terminated and they come back, they often change their IP addresses. And so traditional network security enforcement using IP can be a bit of a challenge. Another interesting and another challenge is the number of environments that people deploy workloads into. I'm not sure how many people are familiar with the AWS account vending machine or the different multi-account architectures that AWS recommends. But a lot of times these environments, they can span not only multiple VPCs or multiple regions with multiple VPCs, but also multiple accounts. We've worked with a lot of customers that segment applications and in lines of business, or they model their organizational structure on an account basis. And often there's not a lot of coordination between the teams, and you find out they have there's overlapping IPs. And you can, and then later on, when you try to figure out what's been going on inside of these accounts, it becomes very difficult to correlate the activity based on IP addresses alone. We've been hearing from a lot of customers that they've deployed existing micro-segmentation solutions inside of their VMs. And a lot of them were just not designed for the dynamic nature of the cloud environment. Previously, you'd have an operator, he'd launch a VM and he'd care and feed for it for the life of that VM. But now, with the cloud, the APIs to dynamically instantiate workloads and VMs are at the developer's fingertips. And they're coming and going, and a lot of the applications that were created to secure those workloads are just not designed for the dynamic nature of the cloud. So the situation that a lot of operators find themselves in is, okay, we need a way to perform microsegmentation of our cloud-based hosts. We need to say, these guys can talk to these guys, but not these guys. And we might have thousands of hosts or tens of thousands of hosts. And we need to be able to enforce segmentation between them. Maybe dev shouldn't talk to prod. We might have a zone-based architecture where we've created a DMZ, a trusted zone, or a restricted zone, and an untrusted zone. And we want to control the communication between these different zones. We need to segment VMs from one another. And what we're hearing from people is that a lot of the solutions that they're using today at scale, it takes a long time for those rules to propagate down to the instances and enforce the policy so they can actually make use of those workloads. I can remember like a few, in a past life as a DevOps engineer, I was running some build servers, and I remember some developers showing up to my desk a little upset about the time it took to launch the worker nodes and actually start to run their builds. And I went and I looked, and it was like 10 minutes. So you can imagine when you're having to wait for a number of VMs to launch, so you can do data processing, or you can train your different machine learning algorithms, and you need to ensure that you're maintaining compliance on those instances. So you want to be able to dynamically instantiate compute, but you also have to adhere to your organization's security compliance requirements. We need to make sure that if there is an issue, that the blast radius is limited, and we need to be able to know what was happening. We need to be able to control what can talk to what inside of the cloud. So the way that we can solve this today with Calico and Calico Enterprise is we can enable automated protection of cloud hosts. And we do that by defining security policies using Calico Network Policy. Calico Network Policy is a superset of Kubernetes Network Policy. And what it allows you to do, what Calico Network Policy is, it's a declarative, label-based network policy mechanism that will allow you to restrict access inbound and outbound from your cloud instances. When new cloud instances are provisioned, the policies are automatically attached to the instances based on the labels that are applied. It's based on instance metadata and the labels that are applied to those host endpoints. And this can eliminate the need to update network security policies for each instance. You can create your policies and then once and have those available in the control plane. And then all you're doing is creating a label taxonomy, slicing and dicing up your VMs, and applying labels to those, and then the policies get applied based on those labels. And we're going to see that in action in just a second here. So Calico Policy is built for dynamic workloads. It's applicable today. You probably are familiar with it inside of Kubernetes. We provide the network connectivity, but we also do the network policy enforcement in a very scalable manner. Calico Network Policy, it's very similar to a firewall, except that the rules, instead of segmenting traffic between the instances of the VMs in this case, we're not going to do it by IP. We're going to do it by label selectors. Things like env equals dev, env equals prod, release stage equals canary, things like that. We can create our own label taxonomy that will allow us to to restrict inbound and outbound access between different workloads inside of the cloud. And this works for pods inside of Kubernetes. It works for nodes that make up the Kubernetes cluster, but it also supports cloud instances and static VMs. And that's what we're going to be focusing on today. So Calico Host Micro segmentation, it can be used as a defense in depth. I'm not saying throw away security groups. I'm not saying get rid of other software-based firewalls. This is another layer of security that you can choose to use inside of the cloud to secure your workloads. We have the ability to enforce policy at multiple points. I think you guys see my mouse here. We can enforce policy inside of containers inside of Kubernetes with an Envoy sidecar. We can also enforce policy inside of Kubernetes at the VEF pair. But today we're going to be focused on host-based services. VMs outside of the Kubernetes cluster that have applications running on them, and we're going to enforce policy at their network border on their physical interface that allows them to connect to the AWS network. Today, we're going to be, as I mentioned, we're going to be focused in AWS, and we're going to be working with VMs, and the control plane is going to make use of Amazon EKS. But this solution is applicable across your on-prem data center, across the other managed Kubernetes environments, and also all the other clouds. And this is advantageous because you can create these policies once and apply them everywhere. So in summary, the Calico, the host microsegmentation protection, it allows you to implement your existing security controls as Calico policies. It allows you to implement policy from a single control plane. Today, we're going to be using EKS, and we also create data that allows us to automatically generate evidence reports and proof of compliance of those policies. All right. And so that is enough of the slides for today. We're going to get going here. Does everybody have this link? I'm going to paste it into the chat. All right, let's see here. I'm going to take a look at the chat here. Is it available in DigitalOcean too? Yeah, absolutely. You can use this. What we're going to do today, minus the EKS portion of the control plane stuff, in any of these environments. So you'll see how it fits in as we go through. So this is available on GitHub in our Tigera Solutions organization. You guys should be able to follow along. I've taken some time to try to make it as simple as possible, and kind of with the understanding that maybe you're starting off with a bare AWS account and you don't have anything running at all. So if you do, you'll see where things fit in. But I'm gonna start off with creating like the base networking environment and all of that stuff, and we'll start to talk about that in just a second. So we want to talk about the Calico host microsegmentation protection deployment considerations. One of the first things we need to do is like, hey, are these VMs going to meet the minimum system requirements? And so you can see here in the docs, we've got our get started, bare metal requirements. And if you see, you come over here, install Calico, we've got our Kubernetes, our OpenStack, and then our non-cluster nodes. So today we're going to be focused on VM workloads outside of the Kubernetes cluster. So we have a couple of different requirements. You can, from a high level, kind of base it off of just like the base operating system version. Today, I'm going to be using Ubuntu 18.04, which I think is like the current like LTS version of Ubuntu. So we're good to go there. And we're not going to have to worry about too much of the networking requirements because we're not doing anything in Kubernetes. This isn't pod networking, but we do want to be cognizant of the required kernel dependencies. And we get this out of the box with the majority of the most recent distributions of Linux. And you can see here, right here, if you're using Red Hat 7, you're good to go. CentOS 7, if you're using Ubuntu 16.04, Debian 8, good to go. All right. And then one of the next things we need to decide is how are we going to install our Calico agent. So the way that this works is Calico, we're going to install a Calico agent on side of our VMs, and that's going to manage and secure the VM workloads. And we can do that a couple different ways. If you are okay with installing Docker on your VMs and you're keeping that running, you can do a container-based installation. If you are a fan of RPM and app packages, you can do a binary installation, which is available for our the Project Calico open source distribution. Today, I'm going to do a simple binary install without a package manager. All right. The last thing that we need to decide is which data store type we use. So for some of you on the call or on the Zoom, I guess, that may already have this running in your infrastructure or be familiar with the solution, you have a couple of different choices. You can choose to use a etcd data store, and now we have made available a Kubernetes data store. And what this is instead of launching and managing an etcd cluster, you can actually utilize the Kubernetes API to access that data store. And that's what we're going to do today. We're going to use EKS. And one of the cool things about EKS is we don't have to actually manage the etcd cluster. AWS does that for us. AWS takes care of the availability, the scaling, the snapshots, the backups. That is all something that's going to be done for us. We're going to, the choice is basically here. There's a setting here, FELIX data store type. We're going to choose Kubernetes. And all we need to do is apply a kube config that allows us to talk to that API, the Kubernetes API, the EKS API, and we'll be able to get up and running. All right. So the first thing that we need to do is we need to deploy the Calico Host Micro Segmentation control plane. And what we're going to do is we're going to start off by launching just like the base networking infrastructure required to stand up EKS. It's a bit of an opinionated, arguably best practice design. We're going to create a VPC. We're going to assign it an IPv4 network prefix. AWS is going to choose dynamically an IPv6 CIDR for us. We're not going to do that today. We're not going to make use of any IPv6 stuff, but we are going to create an internet gateway, public route table. We're going to create a subnet for every availability zone. And we're not going to use any private route tables, or excuse me, any private subnets today, but it's a simple flip for on or off. So, and you have this available to you inside of the repo. We'll go over some of the stuff in a second. If you want to take a look while we're going through the steps, it's this CloudFormation infra.yaml. So some of the stuff takes a little while to stand up. So let's get going. So I'm going to deploy into the US East 1 region today. If you might have your a favorite region, I live in Virginia, so I'm going to be in US East 1. And we're going to start off by deploying the Amazon VPC infrastructure stack, and we're going to do that via CloudFormation. CloudFormation is AWS's infrastructure as code tooling. Some of you guys probably use Ansible, you might use Terraform. Today we're going to keep it as AWS specific as possible. So let's go ahead and launch our VPC. You can see that we're choosing a 10.0.0/16 VPC CIDR, and I'm not going to create any private networks today. All right, so let's go ahead and launch this stack. All right, everybody, you talk amongst yourselves. I'm just kidding, I already did this. So one of the cool things about CloudFormation is that it's idempotent. You can continually make changes to the infrastructure as code, and you can apply it and apply it and apply it. So as you add new security groups, as you expand your cloud infrastructure, you can continuously run the CloudFormation deploy command, and it will continuously update your infrastructure. I've done that ahead of time so we don't have to wait too long. The next thing that we need to do is we need to launch an Amazon EKS stack into the Amazon VPC infrastructure that we just created. And we're going to do that with CloudFormation as well. So the first thing we're going to do, well, there's a couple of things you need to think about too. So a couple of the resources, or the parameters anyway, are the region specific. So Amazon, they bake us an EKS optimized Linux AMI, and they do that for every region. And if you click on this link inside of your tab, you'll be taken to the different AMI IDs that you can plug in here to launch an EKS worker node inside of the region that you might have chose. And that's if you chose something other than USDS1. I'm also choosing a particular instance type. It's a little bit larger than some of the other ones. Another just like standard disclaimer, this stuff costs money. So if you're launching this into your account, be aware that launching instances will actually cost you some money, but we're only launching just two worker nodes. Amazon EKS, they manage the master nodes for us, and we're just going to have a couple of worker nodes to host some of the other pods. We're going to be using Kubernetes version 1.6 for this EKS cluster. This just came out like this past week or so, I believe. I saw the EKS or the Kubernetes GM from Amazon posting this on LinkedIn, so I wanted to make sure that we use the latest, greatest. So let's get that going. And I've already done that too, because that takes like 15 minutes or so to come up. But that's all I've done. This is pretty much the last, the cake has been baked as far as here. And so now that we have a VPC, up, we've got subnets for every availability zone, and we have our EKS cluster launched. Now what we're going to do is we are going to start to configure it as our Calico Host Micro segmentation control plane. The first thing we need to do is we need to be able to talk to this cluster. I'm using the AWS CLI. I'm assuming that most of you guys are familiar with the CLI if you guys are joining here, but if not, this isn't the CLI that allows you to talk to the AWS APIs. If you have a Mac, you can use Brew. If you go to like brew.sh and then you install Brew, you can do brew install AWS CLI. If you're on a Linux node, you might be able to do yum install AWS CLI or apt-get install AWS CLI, or maybe you're using pip, the Python package manager to do pip install AWS CLI. There's a bunch of different ways to grab this, but we're going to be using this to do some of the work here today. The first thing we're going to do is just enable us to talk to this new cluster. So let's do that. All right. So we have we've just updated our kube config, and now we can make requests to our cluster. First thing we're going to do is look and see how many nodes we have. It looks like we don't have any nodes yet, and this is how when you launch an EKS cluster, you start off with the master nodes ready to go, but you actually have to give permission to the worker nodes to be able to join the cluster, and that's what we're going to do next. Inside of this repo, there's an AWS Off Config Map right here. And if you go to the docs, and at the very bottom of that GitHub repo, there's a bunch of reference links. There's some links to some supporting documentation. There's a link to a really awesome video that explains everything you need to know about AWS container networking. And there's also a link about IAM users and the roles and how that works with EKS. This first portion here that I have highlighted, this is going to allow the worker nodes to join the cluster. And then the second part here, this is going to be how we're going to allow the instance profiles that we assign to our VMs to authenticate to the Kubernetes cluster using RBAC. So let me go back here. Let's do this. Come up here. So the first thing we want to do is grab our account ID. So I'm just going to use the AWS CLI to get my account ID. I'm going to assign it to that variable. And then I'm going to update the AWS Off Config Map with my account ID. Okay. You can see it. It's here. It used to say account ID. Now it's got my account ID. All right. So one of the things to note is that you may have a different sed syntax. I'm on a Mac, and it makes you use this like little quote. If you're on a Linux box, you don't need to do that. Just heads up. And so the next thing we're going to do is we're going to apply it. So let's apply that to our cluster. And let's see what happens here. Our nodes are added. I'm going to do it a little bit different. All right. Okay. So we've just given permission to join our worker nodes to the cluster. This will take a couple of seconds here. Just hang tight here until we see the status says ready, ready. So we've got one going. And we have another. All right. We have a fully functional EKS cluster. All right. Let's come back here. And so the next thing we're going to do is we're going to deploy the Calico onto Amazon EKS. So first of all, let's take a look and see what we have running inside of our cluster. Let's look at all the namespaces, see all the pods. So EKS, and it's still coming up, it looks like. So we're using the AWS CNI here to provide network connectivity to pods inside of the EKS cluster. But we're not going to do anything with Kubernetes, really. We're not going to launch any workloads inside of Kubernetes other than Calico. We've got the DNS and we have kube proxy running. It's pretty basic cluster going on. All right, now let's install Calico. And this link here, this is actually from the AWS documentation. If you come all the way down here, you can see the instructions for installing Calico EKS. This is right out of the AWS docs. We're going to grab that. I'm going to come back over here and just paste this in. All right. And then so let's do the same thing. Let's come back here and watch all the pods come up. Make sure that Calico comes up as we hope. And so what we're getting on each one of our worker nodes is a Calico node. And this is EKS, and we're using the AWS CNI. So for any Kubernetes workloads, they're going to get wired up with routable IPs inside of the cluster. We're not using Calico to do that. But Calico is going to be able to provide network policy enforcement inside of EKS, and also is going to provide network policy enforcement to the VMs that are outside of the cluster that we register with this control plane. All right, let me come down here. All right, the last piece of the puzzle here is that we need to allow, we need to map the IAM user to an RBAC user inside of the cluster. And we're going to do that here with this cluster role binding. Let's go ahead and apply it. Let's take a look at it. I don't know how I did that. So what we're doing here is we're saying that we have a user as Calico HMS, and that when this user authenticates to the EKS cluster, it's going to have the permissions defined in this cluster role, Calico node. Let's come back. Okay, so we've now successfully deployed the Calico Host Micro Segmentation Protection Control Plane. It's up, it's ready to go. We've got our VPC deployed. We've got our EKS cluster running inside of the VPC, and we have an EKS API endpoint ready to go to serve as the entry point for our control plane. Then the next thing we're going to do here is we're going to deploy the Calico Host Micro Segmentation Protection, and we're going to launch a stack with, this is an auto scout group, and it's got a no count of 1. So a couple of things I want to point out. Prior to starting this, the demo, I created a key pair. This is just an SSH key pair that you can create inside of AWS, and I've named it Calico node. So you need to do this before you launch this stack, or you won't be able to SSH into your nodes. You also want to, I've also chosen a Ubuntu 18.04 LTS AMI, and this is available in the US East 1 region, and we're going to do a count of 1. So let's go ahead and launch this stack. All right, that's going to go. Let's take a look at AWS. So let's look at CloudFormation. So you can see that we're in progress here, creating progress. We're creating the Calico demo HMS demo environment. We've already instantiated our VPC, and you can see that here. We can look and see all the resources that make up the VPC. And we can see that we also have the Calico demo EKS cluster. We've got the cluster, the node group, and the launch config for the worker nodes. And we also now have a Calico demo HMS node group and launch config. And so this is going to be the example VM that we're going to use to install the Calico Host Micro Segmentation agent on, and then register it into the control plane. So let's do this. Let's find the public IP address for that node so we can interact with it. All right. This is the public IP address for this node. And I'm going to paste this into the chat. Let's see. All right. So the next thing we need to do is we're going to copy some of the installation files that we have inside of here. We're going to install the agent here using this script. This could easily be done as part of the user data for nodes that you launch with your AutoScout group. So this could all be completely automated. You might use Packer to bake AMIs, and you could just bake everything into an AMI to launch your fleets of VMs. I'm going to do it manually today so you guys can see how everything is done. We're going to be using the open source version of Calico. So everything that you see happening here today is freely available to you, and it's all open source. The cluster name is Calico Demo EKS. If you name your cluster something different, you'll want to update this, this variable. If you're pulling from a private registry, you'll want to add your pull secret here. There's a couple of dependencies that we need to have in order to enforce policy on these nodes. We need to have IP set, and we need to have contract. So what we're going to do is we're going to have the ability to do stateful packet inspection across all of our VMs. And we're going to do so with IP tables, IP set, which is a little bit different than regular IP tables. IP table, IP set is like an order one match, super fast network packet inspection. And then the other thing that we need to do is we need to be able to authenticate to the AWS API and also to the Kubernetes cluster. And we do that using a kubeconfig. So I'm using my elite bash scripting, I'm going to render out a kubeconfig, and I'm going to place it at verilib kubeconfig. And this is going to allow us to authenticate to the cluster. One of the nuances of this configuration is that we're going to assume a role. And I'm going to talk a little bit more about this in just a moment. What this does is it sets us up to be able to do host micro segmentation protection across multiple AWS accounts. And we'll get into that in just a moment. So let's continue on here. Let's come back. So I'm SSHing out to the node that we launched, and I should be able to git clone the repo out to that box. Let's see here. That's why we're having an internet snow day. Let's see. Let's give it a second here. Yeah, it looks like the node itself is still initializing. So let's go take a look at it. So it's still initializing. So in just a moment here, we'll have SSH connectivity to this node, and we'll be able to pull down the script, and we'll be able to get going here with the agent installation. While we're waiting for this node to finish coming up, if there's any questions that we have here, let me take a look at the Slack here. Can this be used for classic VMs on-prem infra? Yeah, absolutely. Yes, it can. It can be used on any VM anywhere, on-prem, in Azure, in AWS, and GKE, anywhere at all. Let's see. I guess like everybody else is helping out. All right, let's see. Let's see what's up. I think there might be something going on here with AWS, of course. So as part of the CloudFormation template, we should have allowed any inbound access. My IP is wrong. Oh, good looking out. Let's do this then. Let's see. Let me grab this then. Thank you. Let's see here. Let's do this. Huh. All right, here we go. Yeah, absolutely. All right, cool. Here we go. Back in business. All right. So now what we're going to do is we're going to replace the account ID inside of the installation script. And now we are going to make our way out to that node. Thank you very much for seeing that. This is the wrong IP. And we're going to hop into the installation directory that we just get cloned. See all of our stuff here. And now we're going to do the installation. And this is going to take a couple of seconds. All right. So we are going to install all the dependencies that we have here. Let me move this out of the way. We're going to run through, we're going to install Docker, we're going to install curl, IPset, IP contract, and pip, Python pip, so we can install the latest, greatest version of the AWS CLI. And then we are going to do a describe call against the cluster, and we are going to create the kube config that we need to be able to talk to the API server. Now, you don't actually have to allow the ability to you don't have to have this. You could choose to bake the kube config into the image. You could take the pieces that we plug into this kube config and put this inside of like the secret store if you wanted. There's a bunch of different ways that you could use configuration management to bake this kube config. But the important thing to know is that we need to know what data store are we using, KDD, and then how do we authenticate to it, which is this kube config. Okay. All right. So we'll just give this a second here. Yeah, and I have the Calico demo SSH key. It's added to my SSH keychain, I believe. If I come down here, SSH add -L. Yeah, it's in here. So I was just using the wrong IP before. Thank you for spotting that. All right. So we're pulling down the Calico Cuddle and Calico node containers, and copying out the binaries here. So they should be here. Oh yeah, we copied them out. So yeah, they're in user local bin. Here we go. All right. So what's next? Let's come back here. All right. So now what we're going to do, so we're going to run the FELIX agent on HMS stands for Host Micro Segmentation. We're going to run the FELIX agent, and we're going to manage that with systemd, which comes for free with Ubuntu. And so we have the Calico FELIX. These are basically the variables that configure the service, and this is the service definition. So let's take a look at that real quick. So Calico FELIX. All right. So some of the most important things here are the data store type. As we saw in the docs, we're choosing Kubernetes, and we need to have the Calico kube config. And we're pointing to that kube config that we just rendered a second ago, var_lib kubelet kube config. The other thing that we want to note and point out here is the FELIX hostname. There's a couple of different things that need to match up. We need to have the host name match up with the node name in our host name definition, which we're going to, or our host endpoint definition, which I'm going to show in just a second. And then we have these things here. These are fail-safe inbound and outbound ports. These are basically break glass tier for your VM instance. So we want to make sure that even if we have policy, or we have no policy applied, and we have a default deny, that we can still get in over SSH, that the node can still do DNS lookups, that it can still get an IP address via DHCP, and in this case, can still do outbound over 443 and 80, so it can get to the API endpoint. This is the Calico FELIX is just a set of variables that we use to configure the FELIX agent that's going to be running on the node. And on Ubuntu, the standard location for that is etc default. So we're going to start off by copying that into etc default. if we look in at Etsy default, you'll see Calico FELIX is in there with a bunch of its friends that are configured in similar fashion. And then we are going to copy in the service file. Let's take a look at that real quick. The service file, and you can see we're using this environment file, Etsy default Calico FELIX. So this is just a simple way of configuring the FELIX agent. If you go to our docs and you look at the reference section and you find other variables or settings that you want to set, maybe you want to change the Prometheus stats port, maybe you want to enable some other setting, you can come in here and you can add that variable here and then restart the Calico FELIX agent using system D, and it will apply those settings. So let's grab this and then let's start it, and then we'll do the status. We'll see what's going on here. All right. All right, so you can see here the Calico FELIX agent is now running on our VM. We are in business. You can see here we've completed the first update to the data plane, and if we do this again, let me do this. All right, we're good to go. All right. The next thing we need to do is, okay, so now we've got a VM, we've got a control plane running. We've got AWS is managing etcd for us. We don't have to do that. We've got Calico deployed to EKS. We've got 2 worker nodes, and we're waiting. We've just installed. We've launched a VM, so we've got this node outside of the Kubernetes cluster. And now what we need to do is register that node, that HMS node, with the control plane, so it knows about it. So the first thing we're going to do is let's take a look and see what host endpoints we have. And you can see that we don't have any at the moment, but we're about to add our first one. So I'm going to grab the IP address of this node. And just because I've already messed up one IP, we'll just take a look at it. All right, cool. 10.0.1.16, it matches. And what we're going to do is we are going to add that to the host endpoint definition right here. And let's take a look at that. So the important things that we need to do is make sure that when we configure the agent, that this FELIX host name, this name right here, matches up with this name right here. It defaults to the host name of the nodes, but I like to set it to something unique. If you're planning on doing host microsegmentation across accounts, you might want to either use like the instance ID or maybe even the ARN or some combination, something that has the account ID in it, so it's globally unique across all of your AWS accounts. That will work out well for you. The other thing that we need to have is that the expected IPs need to match. So these need to match up, and then we can apply policy to these to the VMs outside of the cluster. Let's take a look at these labels. So earlier on when we were going through the slides, we discussed a little bit about how we segment traffic inside of across the different VMs. We do that with labels. So I'm applying some labels to this particular node. I'm saying region is equal to US East 1, and I'm saying that the environment type is equal to AWS, the platform type is equal to VM, and the Kate's app equals Calico HMS. These two are going to come into play in just a moment here when we start to apply policy. Let me come back over here. All right, so let's go ahead and register our control plane. All right, so we successfully applied that resource. And now let's check and see if we have it. All right, cool. So we just registered the VM to the control plane. And at this point, we haven't defined any policies, but there's still policies being applied to this VM. One of the things you might want to note is that in Calico version 3.13 in previous, when you're using a named interface like this, you're going to get a default deny behavior. We have the ability to apply policy to you can stick a star here and apply policy to all interfaces. In 3.13 in previous, that would have a default allow policy. we're about to release a new version, and this behavior is going to change. So keep an eye out on our docs in like the next coming weeks. You're going to see some big red squares that bring your attention to if you happen to be migrating from a previous version to a newer version, this behavior is going to change. So right now we have a default deny policy applied, with the exception of the ports listed inside of the configuration for the failsafes. All right, so let's see if we can connect to this instance. Let's do this, because my AWS filter ninja stuff didn't work out for me very well before. So let's do this. All right. So the top portion of the screen is actually inside of this VM, and the bottom portion is on my laptop, which is going to go across the internet to connect to this particular IP. And I'm going to stick this IP in here so you guys can too. Why don't everybody that is on the call see if you can ping that IP and let me know. See if everybody can connect to this particular instance out in the node. Right now, the security groups are wide open. Anybody should be able to connect to this. All right. It looks like it's not working. I can't, for some reason, we're getting a deny here. And this is that default deny. This is what I was just talking about. So right now, we don't have the ability to send any packets inbound to that particular, to this VM that's outside of the Kubernetes cluster or the EKS cluster. But now what we're going to do is we're going to program some network policies that will allow access for ICMP. So the first thing we're going to do is we're going to apply the global network policies and the global network sets. So you can see that right now, we don't have any global network policies and we don't have any global network sets. So let's go ahead and apply these. And you can see now I've enabled connectivity. I've applied a policy that will allow inbound access on from my source, and my source is defined here in the global network set. So let's take a look at those. We'll talk a little bit about those. And then what I'd like is if, yeah, Jonathan, you can't ping. I'll tell you what, why don't you open up another tab in your browser and type in what is my IP and paste it into the chat. And then I'm going to enable you to ping. So here we go. So we'll come back to the policy. We're going to get Jonathan going real quick here. So what I want you to notice here is that I'm not editing the policy. I'm editing the network set. I don't need to change the policy. I just need to change the data that it operates on. So check this out. So what I'm saying here is that every one of these network prefixes, when Calico sees it, it's going to assign the label attendees equals present. So if you're present here today and you give me your source IP, I'm going to allow you to ping this particular node out on the internet. Here, we've got a couple other people here. Let me grab you guys while I'm in here. Hold on a second. Boom. Let's do this. Get a couple of you guys going here at once. 32. Who else we got? Thank you. Got to get John in here because he helped me out earlier. Boom. All right. Dimitri. 32. All right. We'll start with you guys. We'll come back and do some more in a second here. So let's just apply the network set again. So Jonathan, let us know. Dimitri, let us know if you can ping that IP address now. You guys should be able to apply. So let's take a look at the policy. So, yeah, that's awesome. So where did they go? The attendees network policy. All right. So this is an example. This is just a very simple example. You can create some very powerful policies that allow you to slice and dice your VMs and create a network policy segmentation pattern that you can apply across VPCs, across regions, across on-prem, across different clouds. What we've done today is we've selected all of the VMs that are outside of the EKS cluster that have an environment type of AWS and have a platform type of VM, and we are logging and allowing inbound ICMP from sources of attendees that were lucky enough and came to this talk today. So if you were an attendee and you were present today, you have the ability to ping that particular IP address. You also have the ability to hit 80 and 443. But there's actually nothing listening on those ports at the moment. at some point probably add something like a web server on here and say, hey, welcome for attending the talk today. So this is the first part. So you can see that we've created a policy and we're selecting all the VMs, just the VMs that are in AWS and just the platform type VM. This policy applies to just those. If we had an environment type AWS and platform was type VM2 or env equals dev, then it wouldn't apply to those unless we selected those particular workloads. And Calico comes with some very powerful selectors. We have operators like has, so you can say has environment type, things along those lines. The other part is the from part, the source selector attendee equals present. And you can see that we're not saying source IP address. I don't have any IPs in here. I have these label selectors. This is defined inside of the network set. Network sets are pretty powerful. What this allows us to do is take a list of network prefixes and we can apply a label, and then we can use that label to apply policy. This is what we're doing. Everything here we're doing today is Calico open source. In Calico Enterprise, you can actually have global network sets that define lists of DNS names. So if I wanted to do egress connectivity, I wanted to say this VM is only allowed to talk to Google, but not Yahoo. I could create a global network set with a list of allowed DNS names, and I would be able to restrict outbound access to those names. Come back over here. So another thing that we can do is we can take a look. I can see all you guys making connections here, all your source IPs in here. Where are the sources? Here we go. We got a couple of different people that we've allowed. We got anybody else in here that wants to be able to ping? We got Dimitri. Let's get Patrick in here. All right, let's see here. Boom. Attendee set. Let's see here. Boom. My Vim skills. /32. I add you in here too. And we'll apply that. And then you should be able to make connections in here as well. And we can see those packets coming in. All right, cool. And so that is the end of the demo. So hopefully you found this interesting and informative and useful. You all have access to this repo, so you now have the ability to quickly stand up a VPC, a EKS cluster, and then to instantiate the Calico micro segmentation control plane, and then also the nodes, and then how to configure that. So you can get up and going within minutes. We did this like less than an hour. We did some slides. Come back here to our slides. Just bring your attention to the Calico Enterprise accelerator that we have. If you guys want to try out Calico Enterprise, we have a UI. We give you flow logs. You don't have to look at the kernel logs. You can get a central control over all of your Kubernetes clusters using a graphical UI. There's a bunch of threat defense, visibility, and policy creation tooling there. And you can try that all out on your own without having to talk to a salesperson. You just go to tigera.io/trial and then sign up.